Ever feel like deploying Power Platform solutions is one step forward, two steps back? If you're tired of watching your Dataverse changes break in QA or seeing dependencies tank your deployments, you're exactly who this video is for. Today, we'll break down the Azure DevOps pipeline component by component, so your deployments run like a well-oiled machine, not a gamble. Curious how rollback really works when automation gets complicated? Let's unravel what the docs never tell you. Manual deployments versus automated pipelines, where the pain really starts. If you work with Power Platform, you've probably had that moment, hours of tweaking a model-driven app, finessing a Power Automate flow, carefully tuning security roles, the whole checklist. You've double-checked every field, hit export solution, uploaded your zip, and crossed your fingers as QA gets a new build. Then, right as everyone's getting ready for a demo or go live, something falls over. A table doesn't show up, a flow triggers in the wrong environment, or worse, the import fails with one of those cryptic error codes that only means something somewhere didn't match up. The room suddenly feels quieter. That familiar pit in your stomach sets in, and it's back to trying to hunt down what failed, where, and why. This is the daily reality for teams relying on manual deployments in Power Platform. You're juggling solution exports to your desktop, moving zip files between environments, sometimes using an old Excel sheet or a Teams chat to log what's moved and when. If you miss a customization, maybe it's a new table or a connection reference for a flow, your deployment is halfway done but completely broken. The classic, it works in dev, but QA has no clue what you just sent over. Now everyone's in Slack or Teams trying to figure out what's missing or who last exported the real version of the app. Manual deployments are sneakier in their fragility than teams expect. It isn't just about missing steps. You're dealing with environments that quietly drift out of alignment over weeks of changes. Dev gets a new connector or permission, but no one logs it for the next deployment. Maybe someone tweaks a flow's trigger details, but only in dev. By the time you're in production, there's a patchwork of configuration drift. Even if you try to document everything, human error always finds a way in. One late night change after a stand-up, an overlooked security role, or a hand-migrated environment variable, suddenly you're chasing a problem that wasn't obvious 2 days ago, but is now blocking user adoption or corrupted data in a critical integration. Here's a story that probably sounds familiar. A business-critical Power Automate flow was humming along in dev, moving rows between Dataverse tables, using some new connection references. Export to QA, import looks fine, but nothing triggers. After hours of combing through logs and rechecking permissions, someone realizes the QA environment never had the right connection reference. There's no warning in the UI, nothing flagged in the import step. It required a deep dive into solution layers and component dependencies, and meanwhile, the business had a broken process for the better part of a week. Microsoft openly calls out this pain point in their documentation, which is almost reassuring. Even experienced administrators, folks who live and breathe Dataverse, lose track of hidden dependencies or nuanced environment differences. Stuff that barely gets a line in the docs is often the exact thing that derails a go-live. These aren't rookie mistakes. They're the fallout of a platform that's flexible but quietly full of crosslinks and dependencies. When you rely on people to remember every setting, it's just a matter of time before something slips. So the big pitch is automation. Azure DevOps sits at the edge of this problem, promising to turn those manual, error-prone steps into repeatable, traceable, and hopefully bulletproof pipelines. The idea looks good on paper. You wire up a pipeline, feed it your Power Platform solution, and let it handle the heavy lifting. Solution gets exported, imported, dependencies are checked, and if anything fails, you spot it right away. You get real time-stamped logs. There's no more wondering if Alice or Bob has the latest copy. Done right, every deployment is versioned and traceable back to source. No more dependency roulette or last-minute surprises. And here's the number everyone likes to share in presentations. Teams that move from manual processes to automated pipelines see feedback loops that are not just faster, but actually close the door on most failed deployments. Sure, mistakes still happen, but they're caught early, and you don't spend hours untangling what went wrong. More importantly, you get auditability. You can trace each deployment, know exactly who shipped what, and yes, pinpoint where and how something failed. But the reality is this is about trust, not just speed. If your team can't trust the deployment process, if every release feels like a dice roll, then every good feature you build is at risk. Stakeholders hesitate to release. Users get frustrated by outages or missing features. The promise of rapid, low-code innovation falls flat when the last mile remains unreliable. Automation isn't just about saving time or impressing leadership by going DevOps. It's the only realistic way to deliver Power Platform solutions that work the same way every single time across every environment. So with automated pipelines, you get predictability. You get a reliable record of every deployment, dependency, and step taken. True CI/CD for Power Platform becomes possible, and troubleshooting becomes a matter of logs, not guesswork. Of course, none of this happens by magic. Automation is only as strong as the links between your pipeline and your environments. That's where things can still go sideways. So next up, let's talk about wiring up Azure DevOps to your Power Platform in a way that's stable, secure, and doesn't break at 3 in the morning. The glue, service connections, and agent pools that don't break. If you've tried connecting Azure DevOps to Power Platform and watched the pipeline instantly throw a permissions error or just hang for what feels like forever, you're in good company. Nearly every team hits this wall at some point. The pipeline might be beautifully designed, your YAML might be flawless, but just one misconfigured service connection or missing agent setting, and you're staring at authentication errors or wondering why nothing ever kicks off. The reality is, Power Platform deployments live or die on what's happening behind the scenes, what I like to call the invisible plumbing. We're talking about service connections, authentication flows, agent pools, and those little settings that quietly hold everything together or quietly wreck your day. Let's be honest, the concept feels deceptively simple. You create a service connection in Azure DevOps, give it some credentials, point it at your environment, and get back to building your flows. Under the hood, though, it's a web of permissions, tokens, and API handshakes. Miss one, and you might break not just your pipeline, but potentially the underlying integration for everyone else using the same service principle. This isn't just theoretical. I've seen teams work perfectly for months only to run into a single deployment that refused to go through. It always comes down to some backstage detail, an expired secret, a role missing from the service account, or a changed permission scope in Azure Active Directory. Worst case, you can accidentally lock yourself or your team out of environments if you get too aggressive with role assignments. Imagine the setup. You finally get approval to use a service principle for your pipeline, aiming for real security and separation of duties. The theory makes sense. You've got one identity per environment and everything should just work. But then deployment day comes. You run your pipeline and it fails at the very first authentication step. The error messages are obscure. You dig through logs only to find that you missed a tiny Dataverse role assignment, one checkbox, and now your agent can't access the environment. Of course, the logs don't call this out. They just spit back a generic not authorized message, so you're poking around the Azure portal at 11 p.m., toggling permissions and hoping not to break something else in the process. It's equal parts frustrating and completely avoidable. There's a pattern here. One missed permission or a non-standard setup can block the whole show. This is why best practice is to use a dedicated service principle. And here's the kicker. Don't just assign it admin rights everywhere out of convenience. Assign only the minimal Dataverse roles needed for its specific environment and task. That might sound like overkill if you're new to DevOps, but in the real world, this saves you from someone accidentally deleting or corrupting data because an all-powerful service principle had access everywhere. It also means rolling keys or changing secrets is cleaner. If you need to revoke a connection from QA, you don't risk blowing up production. Teams that stick to this separation rarely have the all environments go down panic. Now, let's talk about agent pools because oddly, they're usually treated like an afterthought. You get two main options, Microsoft-hosted agents and self-hosted agents. Most folks grab whatever's default in their Azure DevOps project and hope it just works. For basic.NET or web jobs, this usually flies. But with Power Platform, you'll eventually hit a wall. Microsoft-hosted agents are great for basic build tasks, but since they're dynamically provisioned and shared, you can't guarantee all prereqs are present, like specific versions of the Power Platform build tools or custom PowerShell modules you need for more complex solution tasks. Plus, if you need custom software or integration, anything that isn't in the standard image, you're stuck. And good luck troubleshooting isolated failures across environments you don't own. Self-hosted agents give you full control over the environment, which is a blessing and a curse. On one hand, you can pre-install build tools, SDKs, scripts, whatever your project requires. If you've got unique connectors or a stable set of dependencies, this can save piles of time. On the other hand, you're fully on the hook for machine updates, patching, and keeping the agent up and running. Still, plenty of teams prefer this route, especially if their Power Platform work includes a lot of custom-built steps or integrations that don't play well with shared Microsoft images. One tip that gets overlooked: always run a dry run, test your service connection, and do a trial export before you feed anything important through your pipeline. Just because your pipeline says connected doesn't mean it has the right level of access for every operation you want to perform. That test export, it's your safety net. You'll catch permissions gaps, role issues, and even basic network weirdness before you're knee-deep in a production deployment. Better to find out now than when you're racing against the go-live windows. So what you really want is reliability without surprises. Durable service connections and agent pools are the foundation for everything that comes after. Get these wrong, and it doesn't matter how polished your YAML or how fancy your pipeline tasks are. They'll fail because the basics aren't wired up right. Once you nail this invisible plumbing, the rest of the pipeline process falls into place with a lot less drama, a lot more predictability. The headaches move from "why did my pipeline never start?" to "how do I make my pipeline even smarter?", which is a much more fun problem to solve. With those connections stable and your agents reliably humming along, you've just cleared the first real hurdle. But solid plumbing isn't guaranteed to catch solution issues before they hit production. Next up, let's dive into how automated checks and validations protect your environments from silent errors before they spread. Automated guardrails, dependency checks, and pre-deployment validations. If you've ever watched a Power Platform deployment pass in dev, go through the motions in QA, and then set off alarms the minute it lands in production, you know where this is heading. Problems almost never announce themselves ahead of time. Instead, you get those quietly hidden dependencies, the kind that sit 2 or 3 clicks deep in a Canvas app or buried inside a model-driven app's subflows. As far as dev is concerned, everything looks good. But production, with its own connectors, different licensed users, or a subtle difference in Dataverse security roles, finds the weak link immediately. Now people are scrambling. Sometimes the only warning you get is a user saying, "Hey, this data isn't updating," or a support ticket with a stack trace that offers nothing helpful. The underlying problem? No one checked if all the moving pieces actually survived the move. This is why dependency checks and pre-deployment validations aren't just nice to have. They're your pipeline's immune system. Think of them as traveling ahead of your deployment and shining a flashlight into all the corners where issues love to hide. These automated guardrails catch things like missing child flows, absent connection references, or unmanaged components that never got added to your export. Without these checks, every deployment is an act of faith. You just hope the plumbing underneath your app looks the same in each environment, and you only know it didn't once the incident report lands in your inbox. I've seen this play out more times than I care to admit. One project had a recurring nightmare, a Power Automate flow that worked beautifully in every dev test, only to completely disappear from a production deployment. What happened? It turned out a quick fix had added a child flow as a dependency, and the export process didn't catch that the child flow was outside the managed solution. When that child flow failed to show up in QA and production, the parent logic just silently failed. No error, no warning, just a process that silently turned off, and users confused about why their tasks were suddenly stuck. We only realize after enough users called out missing updates that someone finally found the missing link. By then, hours had gone into combing through export XML files and running manual checks. One overlooked dependency caused chaos that could have been flagged with the right guardrail in place. The real kicker is how preventable this is now. Tools like Solution Checker and Power Platform let you set up automated scans as a pipeline step, giving you upfront warnings about issues with solution layering, missing dependencies, app performance, and even security recommendations. The Power Platform built tools for Azure DevOps bring this even closer to CI/CD reality. With the right pipeline step, you're doing far more than a straightforward import-export. You're running validation checks against both the solution and its connections to the target environment. If you have extra requirements, custom PowerShell scripts let you go even deeper, scanning for things like required environment variables, validating connections for premium APIs, or checking permission scopes on AD integrated flows. What's interesting is just how much these automated guardrails catch compared to the old export it and hope methods. Community studies say these checks flag up to 70% of the issues before anything goes live. That means fewer after-hours calls, fewer catch-up sprints to fix what broke, and way fewer awkward meetings explaining to leadership why a go live became a go limp. Microsoft's own research and case studies back this up. Teams running pre-deployment validation as a rule see a dramatic drop in production breakage, and problems get caught so early they barely register as incidents. A solid pipeline step for this is straightforward but effective. Export your solution from source, but before you even consider importing it to the target environment, kick off a sequence that runs Solution Checker and any custom tests you've added. Don't just stop at the build. Run queries against the production Dataverse to make sure the entities you're about to overwrite don't have schema differences that will cause a silent error. Validate connection references. Don't assume everyone who had permissions in dev or QA will have the same role in prod. Having these steps in the pipeline means the script fails early if anything's missing, and you get useful logs telling you exactly where the gap is. These automated checks are the difference between spending your day building useful features and spending your evening firefighting broken deployments. They don't just keep the environment stable, they actually give the entire team confidence that changes moving through the pipeline haven't skipped some crucial step or missed a last-minute dependency. It turns deployment day from something tense into something routine. When someone asks, "Did the deployment finish?" you can actually answer with more than "I think so," because you've got the guardrails to prove it. It's easy to dismiss pre-deployment checks as another box to tick, but in the Power Platform world, they save more time and face than almost any other automation. Instead of working backwards from outages and complaints, you're getting proactive Sentinel alerts. Early, actionable, and tied directly to components. Think of them less as a safety net and more as a radar system. Of course, even with the best guardrails in place, things can still go sideways. Nothing's bulletproof, and every team needs a way to back out changes when something slips past. So let's get into what a real rollback and backup plan looks like for Power Platform beyond just hoping the undo button works. When things break, building a real rollback and backup strategy. Let's talk about what rollback really means for Power Platform, because it's easy to assume there's a big undo button waiting to rescue you when a deployment melts down. But unlike code projects where a rollback is just a git reset or a package redeploy, the Power Platform world is far less forgiving. There is no native revert deployment option. Once an import happens, changes are baked into the environment, tables might update, components shift versions, and data relationships can quietly reshuffle themselves. If something fails mid-import, the result could be half a solution deployed, broken integrations, or users locked out of apps they rely on. The stakes are rarely obvious until they hit, and by then the fix requires finesse. The hard truth is that a botched import leaves your environment in a kind of limbo. Some components might upgrade, others stay at their old version, and connections or roles could be in an undefined state. Configurations slip out of sync fast, and you're left with a system that doesn't really match what anyone intended. What looks like a minor tweak in a managed solution can knock out entire business processes downstream. This is where most admins get caught. There's a sense that you can just run it again or undo a step when in practice you're dealing with a live application that users count on to do their jobs. Now picture the stakes with a real example. One large financial company had a new feature queued up for their Power Apps portal, some workflow tweaks, a couple of shiny new dashboards, and a reconfigured data table. The change zipped through QA, so they greenlit the import to production late on a Friday, hoping to smooth things over before Monday's reporting deadline. The import errored out halfway through. The end result? Users who logged in Monday morning found broken dashboards, failed automations, and a handful of Canvas apps that wouldn't load. To make matters worse, their last full environment backup was weeks old, and they hadn't exported the latest solution version after last-minute dev changes. Restore options were limited, and the business lost a full day's worth of work while admins pieced the environment back together. No single step caused the disaster. It was a missed backup window, a belief in quick fixes, and a lack of flexible rollback planning that left them exposed. So, what can you actually do to avoid ending up in rollback limbo? The first and most reliable layer is automating solution exports at every stage. Instead of trusting that latest version in a dev folder, your pipeline should automatically export the solution to a secure location, ideally into source control. That way, every release, whether successful or failed, has a corresponding backup. If today's deployment goes south, you aren't stuck with whatever happens to be on your desktop. You always have access to the last known good package. Nightly environment backups are another practical move, even if you think you'll never need them. Microsoft does offer full environment backup features, especially for Dataverse environments, but you'd be surprised how many teams don't actually automate their use. The official guidance is clear: always run a complete environment backup before touching production. Yet, in the field, a lot of teams rely on "we'll do it if we remember." That works about as well as you'd expect once until it doesn't. Setting up nightly or pre-deployment backups means you have a full snapshot to restore from if the wheels fall off. When paired with solution-level exports, you can decide whether to restore an entire environment or just roll back a single solution, depending on the scale of the issue. Version solution files in source control might sound basic, but they're a lifesaver. Tracking every exported zip with commit history, branch naming, and pull requests brings Power Platform deployments closer to classic application lifecycles. You get a full audit trail of what changed, when, and by whom. If a rollback becomes necessary, you don't need to scramble, just redeploy the previous successful build. This isn't just convenient, it's one of the most reliable ways to restore business-critical changes without collateral impact. When it's time to execute a real rollback, exported solution files are your lifeline. Start by restoring the previous solution version that you already validated in a lower environment. Rolling back to that known good state will reset your components, flows, and related customizations. You won't get a perfect time machine, records, or transactional data modified, since the last deployment might still be at risk, but you can return the app to a working configuration, often within an hour. For anything more severe, a corrupted entity, lost relationships, or data integration issues, you might have to use that environment-level backup or slice in individual table restores, depending on what's available. One lesson learned the hard way: never assume your rollback plan is robust unless you've tested it in a sandbox. The difference between a theoretical and a real-life recovery process is enormous. Without testing, you risk restoring incomplete dependencies or hitting import conflicts you didn't anticipate. Practicing your rollback isn't just busy work, it's what stands between a quick restore and an all-day outage. A solid backup and rollback plan means deployment failures become a bump in the road, not a disaster that burns through your weekend. It's the kind of safety net that lets your team deploy with confidence and keeps the business running smoothly even when the unexpected happens. Now, all these moving parts, connections, guardrails, and recoveries feed into one larger question: how do you make sure your whole pipeline works together instead of against you? The line between a fragile deployment and one you can actually rely on never comes down to luck. It's how well you wire up each piece: service connections that don't surprise you, agent pools that don't go dark mid-build, and automated checks that actually do their job. With the right structure, you stop holding your breath on every release. Issues pop up early, not after the fact, and when things break, there's a plan. If you want to keep Power Platform working for your business and avoid late-night fixes, subscribe and join the conversation. The real learning always happens on the next deployment.